Hi, this is Robert Greer. This is PA6 for GAM-575. I'll start by showing some of the converter code. So here in the converter, I have new methods in main to convert the animations, as well as converting the chicken bot itself. So the chicken bot extraction is just this standard code to bring out the individual bones from the mesh, and those get stored in data as the separate bones as proto-azul files, and those bones can then be loaded into the engine just like any other mesh, which I'll use later in the skeleton. Okay, so those are the bones. Next is the animations. So for converting animations, I have some logic here to loop over the nodes and extract out the translation and rotations for every keyframe. And then I do a bunch of printing so that I can get the exact copy of the clip I need to paste into the C++ code. So that looks like this. I already ran it for the sake of time, but I can just copy and paste all this data into a clip, and that will play back in the engine. And then I also loop over the joints to print out the skeleton organization. So I can paste that into the skeleton so that it can be recreated there. So this should be data-driven as a next step. All right, jumping over to the engine, we'll start with those clips. So the clip is a little ridiculous right now. It's just a giant file with all of the clip data. So you can see pretty big line number. It's just all the animations hard-coded in there. And then I can set up a particular one that I want on the constructor. So in game, I created a clip manager, which is a standard manager class singleton that can own those assets for each of the animations, and then I can reference those later by multiple animations. So the clip is managed by the anim class, which has a clip, and then it also has a skeleton, and so it's going to use the clip to animate the skeleton. So the clip can do something called animate bones, which is just finding the right frame buckets, interpolating the time, and then doing the blend, which is just the lerps and the slurps in the mixer. So that's how the animation happens. And what is animating is that skeleton, which is, again, taking the data copied from the converter to set up the skeleton hierarchy. And then it uses that to just recreate it from the meshes I loaded earlier. And that creates this composite game object that will look like this when it's running. So in game, I create several animations, and these animations are going to be owned by an animation controller. So the controller is two things. It's the animation and then also the time. So this allows me to have different timings for the different animations so that I can control their speed and direction independently. And then through this controller, I can set the current clip, and then I can also manipulate the time to speed it up and slow it down and reverse it. So I do that here in game. I set up all my controllers, and then in update, I update all the animations, and then I have keybinds to set the current clip of the main one, and then I also have keybinds to update the speed, and then also to reverse. So I can control all of that. All right, let me run it and show it all working. So here I got my 5 guys. You see they're all playing different clips. You have walk, hit front, sidestep, shot up, and then run in the middle. So for the middle one, I can toggle what it's playing just through 5 through 9. So there's walk, run, shot, hit front, and sidestep. I'll go back to walk so I can speed him up by pressing 2 and slow him down by pressing 1, and then I can reverse with 3, so now he's walking backwards, and then make him go back forwards. And all of that's happening independently of the other animations, and of course the time applies whichever clip is playing. And it's all independent for each object. And then the rest of my demo is just running as normal in the background. So everything's working there. If I close it, you can look at the game object hierarchy. It has those 5 different skeletons within the hierarchy, which is pretty cool, and then it exits cleanly. So that's about it for PA6, and thank you.